In this video, we're going to take a look at how to write equations given the zeros. So remember, when you think about factored form, we looked at factored form of a quadratic, which looked like you have the a value, which tells you if it opens up or down. We had x minus c times the quantity x minus d. So that's specifically factored form for a quadratic function. If the function has more zeros or a higher power, you're just going to have next would be quantity x minus e, and so on. So in our case, with our function of 3 zeros, we're going to set up 3 terms, 3 binomials, and we're going to substitute those zero values into it. You can choose any a value you want to. You can make it positive to open up, negative to open down. Just for the sake of ease and teaching purposes, I'm going to leave my a as 1, so I'm going to drop it out altogether. Alright, substituting 0 in for c. And remembering the asylum, I'm going to put -2 in. It's going to become positive. And substituting -3 in, that will become positive as well. Now in this case, my x minus 0 disappears. Well, the minus 0 disappears. I'm left with my x. And I'm going to distribute that last. I'm going to go ahead and FOIL these two terms and then distribute my x last. So I'm going to get x times x to give me x squared. X plus 3x. The reason I'm doing this and not leaving it in factored form is because the directions told me in standard form, so you've got to FOIL it out. Plus 2x, and 2 times 3 gives me 6. So I'm going to simplify inside the parentheses, combining my like terms to get 5x. And finally distributing my x to put it fully into standard form. Our next example is quite a bit more complicated because our zeros now are under a radical. So note this note off to the side that's in red, kind of important. Radical, and when we get to imaginary roots in section 4, they always come in pairs. So that means you need to use the opposite or the conjugate. Depending on if it's a binomial, you need to use the conjugate. If I had just told you that the 0 was the square root of 2, we would use the opposite. So, starting off on this one again, putting it into factored form. Nice that our first x is 0. That'll make it a little bit less complicated. Now this next one, because the 0 is a binomial, I need to put the whole 0 in parentheses when I subtract it from my x. And I need to remember to use the conjugate. So now I'm going to subtract the 0 of the conjugate. Again, putting that in parentheses. Now there's a couple of different ways to do this. You can distribute your negative and turn these into trinomials and just multiply them out. FOIL does not work with trinomials. You can only FOIL binomials. So you'd have to use distributive property and make sure you distribute to every single term. The other option is to think about this as a single term. Makes the multiplying a little bit complicated. Some of you may prefer to do it that way. My guess is from teaching this last year that most of my students prefer distributing and multiplying the trinomials, so I'm going to do that instead. Simplifying my x minus 0 a little bit, and here when I distribute this negative, I'm going to get x minus 1 plus the square root of 2. And I could turn my brackets back into parentheses as well. Distributing over here, x minus 1 minus the square root of 2. Alright, so for some of you, I'm going to show multiplying the box method because I know you all know distributive property. Some of you may prefer this box method instead. So what you want to do when you're multiplying is make sure that you set up enough rows and columns for each term. So I've got 3 terms in each of my parentheses, so I need 3 rows and 3 columns. Order doesn't matter when you multiply as long as you keep all of these either in a row or in a column. And then I'm going to put these across the top. Then what you're going to do is you're going to multiply and put your answer inside the boxes. So x times x gives me x squared, x times -1, and x times -2. Or sorry, negative root 2. Same thing here, multiplying everything by a -1. And in the last row, multiplying everything by positive square root of 2. And this one, remember, when you multiply a square root by itself, when you take the square root and you square it, the square root cancels. The negative does not cancel, so make sure you still have the negative 2. All right, so I'm going to keep this x, and then I'm going to simplify what's in here. I have 1x squared, so that's going to be my x squared term. And actually, I'm going to change colors here so we can cross them off as we use them. And then I have negative x plus negative x, which is negative 2x. And then I have a negative x root 2 canceling with a positive x root 2, which is really nice. I don't have that mess in my final answer. And same thing here. My negative square root of 2 cancels with my positive square root of 2. So I have 1 minus 2. That should always happen. If you've got radicals or imaginary numbers, they shouldn't be in your final polynomial when you put it into standard form. And finally, I'm going to go ahead and distribute my x. We get x cubed minus 2x squared minus 2x.